A Fortune 500 engineering team's monthly AI API bill cleared $400,000 in June 2026, and their CFO flagged it as a line item larger than their entire DevOps headcount. The model doing the work? Locked behind a proprietary endpoint they can't audit, can't move, and can't negotiate. Then July 27, 2026 hit. Moonshot AI dropped the full weights of Kimi K3, 2.8 trillion parameters, free to download, free to self-host. The largest open-weight model ever released, by a wide margin. 1/3 the cost of Claude Fable 5. Comparable coding performance. Open weights. That combination had never existed before at this capability level. So why can't every organization just download it and go? To answer that, you have to understand what Kimi K3 actually is, and why 3 very real walls stand between this model and easy adoption. Wall 1 is the architecture. The classic complaint about massive models is simple. More parameters means more compute per token, and compute costs money. A 2.8 trillion parameter model naively run would be unusably expensive for most organizations. Kimi K3 cracks wall 1 with mixture of experts. The model contains 896 specialized subnetworks, experts, but activates only 16 of them per token during inference. You pay for 16 experts worth of compute, not 896. Architecture solved. But wall 2 is nastier, long context inference. Processing a million tokens sounds impressive until you see what traditional attention mechanisms charge for it. Standard attention scales quadratically with sequence length. Doubling your context doesn't double your cost, it quadruples it. At a million tokens, this is not a theoretical complaint. It's a budget-destroying reality for any system processing long legal contracts or research corpora. Kimi K3 counters this with Kimi Delta Attention, a hybrid linear attention mechanism. The result, long context inference up to 6 times cheaper, and a 6.3x decoding speedup in million token contexts. Wall 2 falls. 2 walls down. Wall 3 is where most organizations will actually hit their limit. Can you physically run this thing? Here's the honest answer. Kimi K3 is not for everyone. The weights alone require 1.4 terabytes of storage in MXFP4 format, and running inference demands a multi-node GPU cluster. A startup with 2 A100s can't self-host this. That's the real wall, not the algorithm, the hardware floor. The timeline tells the story fast. July 16th, Moonshot AI launches the Kimi K3 API. July 27th, full weights drop publicly. 11 days from API to the largest open-weight model release in history. On the benchmarks, Kimi K3 scores 91.2 on BrowseComp, ahead of GPT-5.6 Sol at 90.4 and Claude Fable 5 at 88.0. This isn't a hobbyist model catching up. It's ranking 3rd overall against the best closed models in the world. For organizations that clear the hardware bar, the use case pipeline is concrete. Self-host on a multi-node GPU cluster, process million-token documents, legal contracts, research corpora, system logs, and run multimodal workloads across text, image, and video, all under one roof with no data leaving your network. The stakes are not abstract. Organizations that stay locked into proprietary APIs pay 3 times more per call, hand their data to a third party, and can't customize or audit the model. That's not a vendor relationship. It's a dependency. What Kimi K3 actually represents is a structural shift, the point where open-weight performance crossed the proprietary threshold. Before this, open models were always a tier behind. The 896 expert Mo with Kimi Delta Attention is the architecture that closed that gap. The 2.8 trillion parameter shock is real, but it only matters if you have the infrastructure to act on it. If this breakdown helped you see why open-weight AI just rewrote the cost equation, subscribe for weekly deep dives on the models and architectures actually changing production AI.